Chapter 13, Developing Understanding of Common and Decimal Fractions.
First, we're going to go over what teachers need to know about teaching common fractions and decimal fractions. It is very important for teachers to make time to use manipulatives. When students are moved too quickly from concrete models to abstract computations, they never fully develop basic understanding of the fractional concepts. Teachers need to allow children sufficient time to engage with various models that represent fractions. Students need to explore the meaning of numbers and build their conceptual understanding.
Common fractions such as 1/2 and decimal fractions such as 5/10 represent the same number, but it is not always understood by students. That is because often the instruction of common and decimal fractions are taught at different times. We often refer to common fractions as just common and decimal fractions as just decimals. Using the terms common fraction and decimal fraction helps students understand that both types of numerals are used to represent fraction numbers. Both numbers refer to parts or units or sets. The difference is that common fraction represent units or sets separated into any number of parts, 3 out of 5 or 3/5. A decimal fraction represents units or sets separated into 10 parts or parts that are powers of 10.
There are five situations represented by common fractions. First one is unit partitioned into equal sized parts. A cake is cut into 4 equal sized parts. Each part is 1/4 of the entire cake. 1/4 represents the size of each piece. The second is in the numeral 1/2, the 2 indicates the number of equal sized parts into which the whole or unit has been subdivided and is called the denominator. The 1 indicates the number of parts being considered at a particular time, and this is called the numerator. Set partitioned into equal sized groups. When a collection of objects is partitioned into groups of equal sizes, the setting is clearly one that involves division. When 12 objects are divided into equal sized group, the mathematical sentence is 12 divided by 2 equals 6. This describes the setting. The comparison model. Fraction relationships can also be represented as a comparison between two sets. Expressions of ratios. The relationship of comparison between two numbers is often expressed in a ratio. And then indicated division. Cutting a piece into 4 equal sized pieces illustrates 3 divided by 4. Another way to indicate this is 3/4.
Introducing common fractions to children. Children label parts of wholes or sets as 1/2 and 2/3 to refer to one part out of 2 parts or 2 parts out of 3 parts. Got a little tongue tied. When students do begin to write common fraction numerals, they should write their fraction with a horizontal bar, not a diagonal one. A horizontal fraction bar will make future operations with fractions, especially multiplication and division, much easier for the child. You can show students that they work with fractions when they help parents cut pizza into, when they share cookies, and quite a few other things that you would use in day-to-day life. These and similar common experiences can be illustrated on a bulletin board to form a basis for discussing the process of cutting things into parts and sharing pieces. Children can fold paper shapes to show 4ths and 8ths to show 1/3 and 6ths.
When the idea of fair shares is well understood and the idea of cutting regions into equal pieces in clear numerals for common fractions can be introduced. Help children recognize that the bottom numeral in a fraction indicates the number of parts into which the unit has been cut, and the top numeral indicates one of the parts. A quick way to assess children's understanding that common fractions represents fair share or equivalent parts of a whole is by using shapes that show examples and non-examples of the fractions. Another example of a representation of a part whose relationship might be a number line. However, one research study indicates that only students who beneficially use a number line in their study of fractions were those who had already developed their foundational conceptions of fractions and part of whole relationships. The concept of a fractional part of a set should be introduced only after children demonstrate that they can conserve numbers, have a good grasp of whole numbers, and are skillful in counting objects and sets.
Many students seem to believe that all fractions are between 0 and 1. so we must introduce them to common fractions greater than 1, such as 6/3. Pictures cut from a magazine can be used to present real-world settings for introducing these numerals. These are called improper fractions, but it is more meaningful to children to call them common fractions that are greater than 1. The term mixed numeral refers to a combination of a whole and a fractional number.
Now we're going to talk about introducing decimal fractions. The goal in early grades is to lay a foundation that enables older students to avoid misconceptions and procedural difficulties. This develops gradually, so work with physical materials, diagrams, and real-world settings and extended over a period of years. Metric units of measure, such as a meter stick, can represent a decimal fraction. Any commercial base 10 product can serve as a model to represent decimal fractions. When commercial materials are unavailable, colored construction paper with half-inch squares may be cut to make an activity kit.
Tens, hundreds, thousands. Decimal numbers indicate that parts of units are involved. A 0 after the decimal, such as 1.0, indicates that a unit has been separated into 10 parts. Rods and a meter stick is used for helping students to understand tenths and hundreds and to show how decimal fractions are used to indicate parts of a meter. When children learn about decimal fractions smaller than hundreds, a large unit region marked into 1/1000th part can illustrate thousands.
Whole numbers and decimal fractions form mixed numerals in the same ways that whole numbers and common fractions do. When children record measurements made with a meter stick, explain that people read mixed numerals that contain decimal fractions in 2 ways. 4.3 is commonly referred to 4.3 meters rather than 4 3/10 meters. Reading mixed numerals with a decimal fraction in this manner helps children build an understanding of the decimal fractions included with the whole number.
Comparing fractional numbers. Children compare whole numbers in many ways. They match objects in one set with objects in a second set and conclude that the one with excess objects has a larger number than the other set. They learn that larger numbers are to be to the right of smaller ones on a number line in numerical sequence, and that the difference between any 2 consecutive whole numbers is 1. When children order and compare whole numbers, they learn that there is an infinite number of whole numbers between any pair of numbers. When they order and compare fractional numbers, they learn that there is an infinite number of fractional numbers between any pair of numbers.
Commercial kits and construction paper can be used to model in which children compare fractions whose number are 1. Number lines marked with common fractions provide a more abstract way to compare fractional numbers than do regions or strips. Children develop their understanding by connecting their knowledge of those models to the more abstract number lines. Children can also use a set of number lines to compare decimal fractions. Display 3 number lines on a large sheet of paper, one showing a unit, one showing tenths, and one showing hundreds. Place one above the other so they are lined up. An important concept about numbers that there is no smallest fraction number can be developed by using number lines. Different modes of representing numbers are not always evident to every child. One important goal is to help children connect the different representations of numbers and make sense of them.